Hey guys, welcome back to the shop. I have a stack of steel flanges right here that need some drilling and tapping. This is a job I'm going to be doing for the welding shop, and I'm going to be using our Milltronics CNC mill to get this job done. This is a type of job that I have done countless times throughout my career on a manual machine using the DRO, setting up the bolt circle diameter function on there and hand cranking to each hole location. Well, this time I got a little bit of help. I'm going to be going to our CNC mill, and with any luck I'll have a program written that I can input in the machine, and we can come in here and quickly drill and tap both of these hole patterns here. So that's what we're going to get started on. I will say that they're 3/4 inch A36 steel plate, so it's just mild steel. They are burned on the ID and OD. That dimension is not super critical. The end user said that doesn't matter. I can't tell you what it's actually used for or where it goes, simply because I don't know. That's common with this type of work. You get it in, you don't know what it's for or what it does, but I feel confident because I know who it's for that this is probably something to do with a water pump system. But where it goes and what it actually does in the end, I don't know. Our job is to put some holes in it and put some threads in some of these holes and give it back to them, and that's what we're going to work on. So I'm going to use Fusion 360 to create a program to be able to do this. I went ahead and just made some notes right here on this original sample piece, and these bolt circles are kind of specific. I ended up using Dad's vernier caliper and measuring these bolt circle diameters to make sure I was on, and I was spot on. So this inner hole pattern right here, those are tapped half 13. You got 8 holes. That's on an 11 and 9/16 bolt circle. All right, and in these outer holes, those are drilled 9/16. It's a clearance hole for a 1/2 inch bolt is what I was told. So we got a 9/16 by 8 holes on a 14 and 1/8 inch bolt circle diameter right there. They are positioned on there concentric. If you look at my note right here, if you look at this at 0, this is 22.5 degrees in between the drilled holes there. So pretty simple right there. So we're gonna get it hopefully drawn up using our Fusion 360. Another really great test job for me and practice session using our CNC mill. So I'm going to jump in there on the computer and start creating a program for this, and I'm going to bring you along for this job. We'll get it set up in the mill. This is going to be a little bit tricky for me because I haven't done a job like this in the mill before. Everything that I've done has been in a vise where you don't have clamps over here in the way, so we've got that to deal with. And so that's it. Let's go ahead. I'm going to get the program made and we'll bring you back. We'll go over to the mill and we'll get this one set up because I want to use the sample, and I'm probably going to set it up on some blocks and then use our toe clamps in between the holes there to get it held down in place. Okay, so here's a look at my setup. It looks a little bit hokey, but I believe this is going to get the job done just fine. I'm trying to be mindful of my clearances, not only for the tools themselves, clearing the tops of the clamps and the flange nuts and things like that, but also anything that might be sticking off past the table on this front side. Like this clamp right here is just barely sticking over, but I brought this all the way forward and shut the door, and there's still plenty of room right there. So I don't have to worry about that. We're not going to hit that. We've got clearance. And the same thing on the back side, this clamp right here, you pretty much can't be overhanging the back of the table right there, or the fixture plate, because it gets really close to the guard right there. So you got to just be within the perimeter of the outer dimension of the fixture plate. All right, and then so these blocks right here are going to be kind of acting as our V block or our positioner. So what we'll be able to do is grab our material, set them down on the 1, 2, 3 blocks there, and just pull it back this way so that it registers here and here. And then go ahead and put our 4 toe clamps on there. We are clamping over the 1, 2, 3 blocks, and I positioned it in that way so that you had equalized pressure all the way around there. So you basically have 3 holes in between the 1, 2, 3 blocks, every single one of them. I could have positioned this one around here and had like 2 blocks right there, but then that gives a whole lot of area right here that wasn't supported, and none of my machinist jacks would actually fit underneath this to support that. So I decided to just go ahead and put it back there so that we have 3 holes in between all of our 1, 2, 3 blocks. I went ahead and swapped out this tool here, which is our mill drill. We use it for spot facing and chamfering. I did have this in a collet chuck. Decided to go ahead and use one of our Heimer 3/8 shrink fit tools, and that'll just live in that holder right there until we have to swap it out. But this way we have a lot more clearance coming around these toe clamps. And the only place I was really concerned about that was when we come to this hole here to do the chamfering. The nut for the collet chuck was a little close to that clamp there, way closer than what I was comfortable doing. So that's why I decided to go ahead and put that in a shrink fit holder, and that it should clear that hole just fine. And all of our other clamps here, it should clear everything just fine. So I feel pretty good about how everything is set up there now. I was using the sample piece so that we can get an accurate location of where all of our holes are going to be drilled. So I have everything ready to go. Now we got to move on to taking this guy out, put a new piece of material in there, and then get it probed so that we can find our G54 work offset, and then we can begin our machining. All right, I'm going to go ahead and remove the sample piece here. Go ahead and set our first work piece in. I cleaned the table really well, and I just used a Sharpie marker and went around all 4 of the 1, 2, 3 blocks and made a mark there. I don't know if the mark's going to stay. Hopefully they will, but that way I don't lose the position of the blocks every time I swap this out. So get rid of some of this rust that was on the sample there. We do have a couple little spots like that on all of them there that we got to be mindful of, so I'm going to make sure that that's just positioned away from our V that we built in here, our work stop. Just like that. Just got it pulled back against the 2 blocks, and that should be pretty good. Only 6 of them to do, so I know there's definitely a lot of better ways that this could be set up to be done, but this is going to work for 6 of them right here.
Pull back.
Oh yeah, it's pulled back. I was seeing a gap in there, but what it is, it's the kerf, so it's touching at the bottom of the plate there. I do have some brass shim stock underneath the foot of the right height clamps here. Okay, we'll go through our probe cycle so that we can find, this is going to be our Z0 is the top of the workpiece here, and we're going to find the center of this right there. Now I know that that's a plasma cut hole, but these are all very, very close tolerance on all 6 of them being cut to the same size. There's clearance burned in here. There's not a critical dimension on the OD, but they're nice and concentric, so it doesn't matter that we're going to be touching off out here on the outside to line up each workpiece and then locating in the center. It's going to be just fine. Lots of clearance on this piece. The main thing is that we have our hole pattern accurately drilled and tapped in there. All right, let's get our probe up out of the way a little bit. We're going to go ahead and X over about to the center, X and Y to the center there. So let's go ahead and just get a reading. It's supposed to be 10.5 on our ID, and that looks right. By the way, on these Starrett hook rules, the hook itself is 250 thousandths wide. So if you butt the end up, you just add a 1/4 inch to whatever you're reading right here, and that'll give you your accurate measurement. So if we swing that around, it looks like it's right on 10.25. So it should be right. 10.5 is what our inside diameter is there. I just like to get it pretty close here. So it should be 5.25. That's pretty good right there. And then we want to go 5.25 this way as well. So Y. Okay. That looks pretty good. I am going to bring that back. I'm taking note of my X dimension. That is 265, plus 265. But what I want to do is bring it over and just make sure that we're down inside of our bore. Because you got to be at the depth that you want to probe at. That looks pretty good. So let's go back. We'll go back to plus 265. Okay, I think we're ready to go. I've got it in bore operation, 10.5 diameter, G54, X0, Y0, and we are ready to run it. This always makes me nervous, so I slow the rapid down. I'm at 40%. Let's see how it does. Cycle start. Okay, well that worked pretty good. Obviously if I had it on 100%, that would be a little bit faster, but I'm not in a hurry right here. So we have our work coordinates now. There's our X and Y 0, and we've already zeroed out Z. I think we're ready to test this out. I did want to note that to start this right here, we're going to be using some high-speed steel drill bits to get this going. But as I got into this job and once it was approved, I actually made an order for a solid carbide 27/64 and also a solid carbide 9/16. I've already got one installed in the tool back there. I also got a couple more half 13 taps. I made that order from Walter Tools. They should be here. I'm hoping tomorrow they'll actually be here. And if they get here, I'm going to swap those out. We're going to change our feeds and speeds in the program to run solid carbide on there, and that should speed up the operation. I'm slowly building up some of my carbide tooling to be able to do these jobs. I'm just ordering tools as I need as these projects arrive like this. So I got plenty of high-speed steel, but I'd like to kind of lean into more of the carbide tools for our CNC work like this right here. But I think our high speed is going to work fine, and we'll go ahead and get our first test piece going here. Let's give it a try, shall we? All right, so first op is going to be spotting all the holes. I'm going to start nice and slow so I make sure I'm not crashing, or I'm going to try to, I don't want to shove that drill through the workpiece here. So my hand is on the rapid knob here. And I want to make sure that everything is clear before we go all the way down. All right, that's all right. There's our 200 clearance. All right, see, like that right there. Let me stop spindle. This coolant nozzle right here is going to have to probably come up a little bit, and I'll have to make an adjustment on the position of it. But like that right there, it almost hit. Okay. Our next hole. Goes fast. That's that 10% rapid right there. Get past this first one, maybe the nerves will relax a little bit. Yeah, I want to make sure it's going to clear that clamp, and it is. So that position right there is why I used the shrink bit holder, and I'm glad I did, because it would have been a lot closer to that clamp, plus the nut it was just really, really close. Another benefit of those types of holders. Okay. All right, starting off with our 9/16. So I'm gonna have to get our coolant position there. Looking for, there's the 200 thousandths clearance height, so we look good. Tell you what, before we muddy up the waters there, let's see how the drill cycle is going to do. There's our 0. Man. All right, that's right there. I stopped it. It looks like it is just barely going to clear that clamp back there. Yep. Had just enough room. Let's try 100%. I think we got her. I'm going to go real slow by all these clamps just to make sure that it's clearing. Come on. Coolant off. Walk it by it. Real close. A little too close for comfort, honestly. I want this one also to go very slow. Right here. All right, turn the coolant off because that one looks like it. It's also very close. Wow. All right, I'm just gonna stop it right there. It's actually gonna clear, but I mean, it is just so close. Let me see if I can get a little bit of clearance out of that clamp, just a little bit. Coming back, yeah, position it over like that. How about that? So whenever I do this clamp, I need to make sure it's pulled all the way back against the stud right there. If we needed to, we could take those ride heights out and put a toe clamp in there. All right, spindle on. Walk by it. Okay, flood on. Drill's doing a good job, by the way. Brand new reduced shank 9/16 drill. Okay. Couple hairy moments in there, but we did good. Now we got our tap size. Pull it off. Let's check our clearance. All right, 0.2, so it looks good. That peg cycle is working great. All right, so our inner holes, we shouldn't have any problem with clearance, just those 9/16 holes. I may make some improvements with our clamps after this piece to try to give us a little bit more clearance. Okay, next is gonna be the tap. All right, main thing I wanna do here is, again, check our clearance. All right, coolant off, get that out of the way. Looks like we're gonna be good. Take it down to 0.2. There's our 0.2 clearance. Oh. All right, I wanted to adjust our plug coolant a little bit better. There we go. That's 100% rapid there. Last hole. Success. I love it. That rigid tapping on these mills, boy, it makes me nervous. All right, now we're gonna do a chamfer. Same thing, let's bring it down nice and easy. Turn that coolant off. Clearance, yeah, that should be right. Let's see. Hopefully this is gonna work out as well. I'm gonna just take it in nice and easy. It's chamfering it, but I could go a little deeper on that. I need to modify that and make it go a little deeper. Making sure that we're clearing our clamp again. And we are. And job complete. We didn't crash. All right, I'm happy with that because we did not crash anything or tear up a tool or anything like that. But I do have a couple things that I need to go in there to the Fusion and change on the program. It's these holes right here. I want to make that chamfer just a little bit deeper. I made that 10 thou, and I'd actually like to see more chamfer on that. But I also noticed that some of these holes, like that right there, they actually didn't go quite far enough down through there. I thought I made it deep enough where it drills through it, but we need to modify that position and make that a little bit deeper, because this one it went through and this one it went through, but it's just enough that it's trying to catch that bottom piece right there as it's kind of come through. So I'll make a modification to our program and then reload it up in the machine right there, and then just run through those particular cycles to finish that out and fix that. I thought it'd be easier just to kind of bring you here to the computer to show you what modification I did. So what I decided to do is that instead of worrying about crashing those tools into those toe clamps, I changed the retract height so that the drill would actually retract to a higher position, so I ain't got to worry about it crashing into that. If I go over here to, it was this guy right there, that drill, you can see the yellow lines there. I had that set. I had all the tools set at 0.2 inches clearance height. You know, you do an op and it goes down here. The problem is there's a clamp down here in the way. So now we're going to actually retract 1 1/4 inches up, and then come over and then back down to our clearance height of 0.2 in between the 9/16 holes. Now there's not a reason to do that for our 1/2 inch holes, because it's further in, there's not going to be a clamp in the way. So I didn't change the clearance height for those holes there. But since I was worried about the chamfer tool on our 9/16 holes, I went ahead and changed that as well. You can see our height is much higher there where it comes over into each hole. So I thought that was just a better, that was the better solution instead of worrying about hitting those clamps. So we did also go in there to adjust the depth, and that's this guy right here. Let's see, we edit this one and come over here. Probably can't see that, but it's our heights tab right down here where it says breakthrough depth. I had that set at 30 thou. I thought it was enough, so I went ahead and changed it to 65 thou so that the drill will go a little bit further and hopefully clear it. It should clear it perfectly now. So I have those modifications made. I did change the depth of the chamfer as well, and I had actually done that in design. I actually added a chamfer to these holes in the design, so I had to come back in here to the design and change the depth there. So I've got that modification made, and come back here to manufacture, and I think that this is ready to go. I've already posted it back out to the thumb drive, and I'm just going to rerun those tool paths and see if that corrects the problem that I was having. I'm not going to run you through the whole program again, but we'll do a couple tools. So I've got my 9/16 drill selected, and I need to go through there and make sure it punches through all the holes, but also this will let us check the clearance height. Our clearance is the same, 200. What I did was I changed the retract height. I think I showed you that. And go back up to 100 there. Yep, that's much better. So that right there is what I was looking for. I'm going to stop the spindle there. I just wanted to go ahead and get the cutter up past all these clamps so we wouldn't have to worry about crashing into it. Start spindle. Let's go 100%. It really didn't need much in the bottom of that hole. I mean, it was like it was right there on it, because like that hole there, it actually punched all the way through. But the material, that being plasma cut, it's not 100% flat, so you got a little bit of a waviness to it there, probably 5/10 thousandths max. So it's going to change a little bit. So this will be a good test as it shoots over to this hole. Yeah, that's much better. That's the only way I can understand and get a little more efficient at this stuff, is just to do it, and a little bit of trial and error. And of course, big thanks to Kevin for helping me with my training. And whenever I kind of get hung up on the stuff, I'll shoot him an email, and usually he'll respond pretty quickly and you know, kind of coach me through what I need to do. So this is the other one that we were worried about it clearing, so we'll just leave it at 100. Yep, perfect. So we'll finish out those holes and then we'll do the same. I made that chamfer for those holes. Instead of 10 thou, I made it 20 thou. Make it a little bit more pronounced. I had to teach myself a little something right there. I wanted to select a certain line in the program to start from. In this case, I wanted to do the chamfer, so I had to go through there and find it, and I was able to select that line and do a non-modal start from there. Let's see if I chose the right one. I think I did. Yep, should be right. There we go. We got good clearance there as well. 1.25 inches, same as the drill. This would be a good one here because of that clamp. I'll just let it run through that. This is the last op right here, chamfering that tapped hole. All right, so number one is finished up there now. Our little modifications work good, and I think the changing of the clearance height for the tool was the obvious choice right there. I just didn't think about that going into it with our clamps in the way, so I'm always learning and trying to figure out this the CNC stuff. We've got success. So this is part number 2. I didn't get any video of this one. I just wanted to go ahead and run it without having to fuss with the camera and you know, keep my hand over here on the rapid button there. But our modifications to the program worked really well. Changing our clearance height of the tools to 1.25 inches, so I didn't have to worry about crashing into these toe clamps right there. Greatly reduced the pucker factor, and I was able to comfortably set it at 100% rapid and watch it go through the cycle, and we had no issues there. The depth is much better. I feel better about that. And then, of course, movement of the tools. One thing that I did go back and change again after that, after I showed you on the computer, is the very first stop with our spot drill. I went ahead and changed the clearance position of that there as well, our height there. I changed that to 1.25 inches when it comes around and spots all those. I wanted to do that as well, make me feel a little bit better. But the part looks good. It's right on size. Everything looks really well. So I did want to point out, so we're at 10 minutes and 42 seconds cycle time on that. I'm going to go ahead and put another one in there, and I'll just do handheld, and we'll just walk you through some of the operations on that. And I'm hoping that later on that the carbide tools get here, and I would like to get the carbide drills installed and finish out the last 3 using those. This isn't a big rush. I've still got a few days on getting these turned around, so it's not like these have to be done today. So I would like to kind of do a comparison of our high-speed steel drill bits versus our solid carbide whenever I get those in my hands. Okay, we've got a fresh flange loaded up in there and clamped down. Let's go ahead and walk you through the program. I had a lot of folks mentioning being able to show this maybe as a split screen on some videos as well. So I'll leave the graphics up here so we can kind of see what's going on. The red lines is your tool path, and of course the green is the holes that we're cutting in there. So let's go ahead and give this guy a start. Let's bring that down to 100. Now what I've got to do occasionally, like right here, bring it down to 0 and adjust the coolant, get that going. I think that was right at that tip, and that worked good for the drills right there. This is the one that I mentioned. I went ahead and changed the clearance height of that as well. You can see it comes up to 1.25 inches here. It should speed up a little bit on this one. I'm thinking. I turned the optional stop off. I actually like having that on so that I can check things and adjust the coolant if I need to. We'll be going with a 9/16 drill next. I just need to adjust the coolant. So bring the feed knob down just so I can get in here and make an adjustment on the coolant there. Clearance height's working really good. All right, tool change, going with a 27/64 drill bit now. See if we need to make an adjustment on the coolant. No, I think that's good. You guys ought to check out that Piranha cooling line. I think they're excellent. This is the little kit that I got right there, 1/4 inch system. It's like a little sampler kit. And they work a whole lot better than the lock lines there. They got all kind of different tips you can put on there. You can customize it in any kind of configuration you want. Lock them in place so that they don't move around. If chips hit them, they don't move out of the place. All right, we'll let it finish out drilling the holes right there, and we'll bring it back. I'm running the tap kind of slow, 150 RPM. I am slowly getting used to the higher speeds at which you can tap on a CNC machine. I'm so used to the manual, putting the tap in a drill chuck or an adapter, and turning the spindle on about 50 RPM and letting it power tap. So we'll get there. We'll get a little more accustomed to the faster speeds we can do with our high performance taps anyway. But as a manual machinist, it is always fun to watch this operate. A lot of pucker factor right here because you really have no control other than just reaching up here and turning a knob or something. I think our video's doing much better without the work light on there. Been using my little El Cheapo clip lights with my warm lighting that I love. I think it works better. You can see how it just really just kind of blows it out. All right, tool change time. Going back in with our mill drill tool there for our final op, which is going to be chamfers. Modified those to be a 20 thousandths chamfer. I have the tapped hole chamfers at 50 thousandths. Clearance height working much better, making me feel better anyway. That move there, I'm a little confused about. It may have been in programming. I've got to figure out if I need to select the holes in a different pattern the way I did. It's only adding another second, but big production run, I know that's a big deal there. We're only making 6, so we'll get by. All right, done. I've got to figure this out there as well. I've been trying to see if Fusion can help me whenever the job is finished, if it'll just go Y home instead of XY home. Right now it's sending everything into XYZ home. Not a big deal. You can come right in here and do jog and X negative and bring it right back to the middle. So there we go. We got a good working program on these flanges now. All right, guys, well, it is the next day and my carbide drills arrived. So I've got 2 solid carbide drills. I got these from Walter. These are the Walter Titex drills, solid carbide. So we have a 9/16 here, and then we have our tap size 27/64. I've got to get these in there. I'm going to replace the 2 existing tools that we already used with these tools here. So I have to get them touched off and get them set. And I have already gone into Fusion and I have copied the program and I modified it. So the change that I made with this is that we're not going to be running the spotting op on here too. I don't want to spot face it for the drills. These are 140-degree angle drills, and the length that they are is recommended if you're going into a flat face there, that you just go right in there with the drill. So we're going to eliminate that so I don't have to worry about chipping the drill and breaking it or anything. We're going to eliminate the spotting, and then drilling it, we changed our feeds and speeds to the recommended speed from Walter for the carbide, and I think that was it. Just made some changes, tried to optimize it a little bit. So I'll get it in here, get it set. Probably not going to fuss with the camera for the first one because I want to make sure all this is right, and if everything goes well, I don't crash anything or break a tool. I'm going to bring you guys back and show you the updated program and how it does machining it with the solid carbide drills. I forgot to mention that I did not get the new half 13 tap. That one happened to be on back order, so we're just going to continue using the existing Cleveland half 13 tap that I got in there right now. It's doing a really good job. I'm making an air run on this guy. I just changed the coordinates to Z to like 3 inches above, so I just wanted to check everything. But I can tell that this is going to be much faster than previously using the high-speed steel drills. So we're doing the last bit of the chamfers now. We're at 5 minutes, which is already half of what I had before, and it's nearly done now. See what we end up at. There's a few seconds extra. There's a few seconds extra for me hitting the cycle start because I do run the optional stop. So it looks like we're at 5 minutes and 13 seconds. So that is half of what we were running with our high-speed steel drills. I did speed up the RPM of the tap from 150 to 230 because I found out what the optimum surface speed was for that. There's a few other things that I could do to reduce the speed, but honestly, when you're just doing a few parts like this, not a big deal. I just know people are going to say, hey, you could do this, you could do that, and optimize the speed. I know I'm working on that, and that's what I am learning and trying to figure out over here. So I'm real happy with that. Next thing is to actually cut it with our carbide drills. I wasn't going to get this, but it's always fun first time. So look at that drill. That's at 9/16. It is just flying through that steel. And it looks like it's making a beautiful chip. All right, tool change. All right, in with the 27/64, and it's doing a beautiful job. That is just awesome. I absolutely love it. Man, that's doing good. Our tapping cycle, where I sped it up to 230 RPM, doing just fine. On the last stop now, I'm doing the chamfers. Sped it up a little bit too. There we go. Okay. All right, so that's our first one finished with our solid carbide drills. It did a beautiful job. So what I'm gonna do on the next one, I'm gonna take optional stop off and I'm gonna let it run through the whole thing without having to hit the button there, and we'll see what our cycle time is there on the next one. But super happy with the way those Walter drills are doing. Just an absolute beautiful job. Even the hole looks just gorgeous down in there. Really like the look of those chips. All right, that was our next one there, and I'm real happy with it. We were able to get our cycle time down to 4 minutes and 45 seconds. So that's less than half of what I originally started with. Really, really happy with that. But I don't know if you guys can see this. I just realized that this is a bad burn right here. You can see how close it is to the center of the wall there on these two holes, and how far out it is on that side. So for whatever reason, this ring was not burned concentric. The other ones look just fine. So I'm actually, I'm gonna have the welding shop go ahead and burn me a couple more, and we'll just replace this one right here with one that's right. I don't know what went wrong. I didn't burn them out, but you can see that this is a problem right there. But the OD is the same. All these holes are good. It's just the center hole is like offset to one side. So they ain't no problem. We'll get a couple more burned out and get it in here and get them cut. All right, it is the next morning. I've got 2 new flanges. Joe burned these out for me this morning. We got them all dressed and we are ready to go on those. I've got the Kaiser fired up, topping off the tank so we can apply some fresh clean air to our spindle on the Milltronics. And this is my little deburr station using the flex arm there. Once I get the last 2 drilled, we'll come over here and finish deburring all the holes there. This is the bad one, so we'll just have that in our little drop pile for a, I don't know, a conversation piece. We'll get the last 2 drilled and I'll just deburr all these at one time. So other than our bad little burnouts, I think the job has been going really well. So 2 more to do. I think I'll try to get some close-up shots of the drilling and tapping for you to share in the video. Other than that, this is about finished up now. All right, guys, well, there it is. This job is completed. We've got them all deburred now over here on the flex arm, and they all look good, and they should all be on size. This was another really excellent training exercise for me, being able to go in there and practice and train with Fusion 360 to sketch this out, using the manufacturing part of the program to do all of our cam, and then of course coming over here to our Milltronics and using this mill to get our job done. It worked out really well. Next job, I got to get in here and get all this cleaned up and get all the coolant off, put all my tools away. But it worked really well. We made just about all the use of our Y-axis that we could on this machine for this job, and I couldn't be happier with the outcome. Worked out really well. So I'm going to go load these guys up and drop them off at the welding shop. And at least now in the future, if they need some more of these guys made, we've already got a program in the Milltronics ready to go. So I hope you guys enjoyed watching. This is another job where I'm kind of sharing my journey into learning how to operate our CNC machines and be able to come over here and utilize these guys as well for jobs like this. And you can see that after the initial programming time and setup time that it takes and proving the tool paths and all that kind of stuff, we were able to get these machined in under 5 minutes, and then maybe another minute coming over here and deburring it. So it goes very quickly. If I had to do this over on the manual mill, obviously it would have taken a lot longer. If I only had to do one of them, I probably would have went over there to the KBC mill and just done one of them. But even just doing something like this, just onesies, is a great use for the Milltronics with your conversational programming on there. But for me, I'm trying to learn how to use CAD and CAM Fusion, and that's what I'm going to continue learning, how to do these jobs. So I hope you enjoyed watching. I hope it was fun for you. Maybe you got a little something out of it, and I really look forward to continuing my journey with the CNC work and sharing what comes through the door and what we can do over here on all of our CNC machines. All right, guys, we'll see you on the next video.